everybody, and welcome to another edition of Math with Mr. Douglas. Today we're looking at the transformation topic of rotations. Yes, we're going to turn things upside down and get right to it. Here we go. So today we are spinning around and doing some rotations. Should be a good lesson, hopefully. Let's get right into it. What we're talking about today in our transformation lesson is going to be about rotations. So we're going to be rotating stuff. That's the technical term, stuff. So imagine we had this little thing and we had to go and rotate it. Now most of today we're going to talk about rotating around the origin as the fixed point. So let's say we had to go and just rotate this. And let's say it ended up, let's just say it ended up over here. Okay, so it went like that. Let's give it some letters. Let's call this A and A prime. So it's going from this to that. And I want to know, and it's going about the origin. I just want to know, like, how did that happen? So if I went and drew a line, look how straight those lines are. This is basically what I want to know. It's going in this direction. So we need to talk about what direction, what kind of words we call that. So what do we call that? That direction. We'll talk about that in a second. And I also want to know how much of an angle. How much of the angle. So we have a couple of things going on that you need to know when you're talking about rotations. The first thing is what direction is it? And the second thing you need to know, of course, is how much of an angle. So those are the two things. So that's what we're going to be kind of looking at today. So if I want to go and rotate that around a fixed point. So this is our fixed point. And I said today mostly our fixed point will be the origin. Let's get right to it. So when we're talking about directions, we obviously have two types of directions. And the types of directions that we're going to be having is going to be clockwise, and counter clockwise. Now you will find there are these crazy people in the world that don't say counter, they will say anti. Oops. They say anti-clockwise. I like counterclockwise. So those are the directions. And obviously when we're talking about a circle, how many degrees do we have? We have 360 degrees. Which there was a student who asked me, like, why are circles 360? I thought that was a really good question. And it has to do with, I think, the Mayans and their fascination with 60s. And basically kind of counting, looking at the stars and the sun and the rotation. And of course we have 365 days, I guess in a quarter in the calendar. And thinking about is about 360 for a rotation. So that's apparently kind of where 360 kind of came from. So that was kind of interesting. Let's give you the down and dirty rules. So they're just straight up rules about how to go and do this. You're going to draw, if you're taking notes, a giant rectangle that has 3 columns and 4 rows. Try and make your rows more straight than mine, and that's a really slanted box, but that's okay. And I'm going to be writing things down in terms of R, which means rotate, and I'm going to put a number kind of in the lower right hand corner. So what this means when you see this notation, it means rotate, and it also means how many degrees, like that. And we're going to be looking at things in a couple of different ways. We're going to rotate either counter clockwise, or we're going to go clockwise. And I'm going to tell you what the rule is. So what happens to the x and y coordinates? So the first ones that we'll look at is going counterclockwise, rotating it 90 degrees. 90 degrees counterclockwise. We're also going to be looking at going 180 and 270. And this is all about the origin. Now a couple of things when you think about your little clock. So here's your clock. What's the clock's name in Beauty and the Beast? Is it Cogswell? That's Cogswell Clocks. Something with a C, isn't it? Okay. So if I go counterclockwise 90 degrees, and if I go clockwise 270, do I end up at the exact same place? I do! That is so cool. So if I rotate counterclockwise 90, I'm actually going clockwise 270. It's going to end up at the same spot. And obviously if I go 180, it doesn't matter which way I go, I'll end up at the same spot. And if I go counterclockwise 270, it's like going clockwise 90. So some things to kind of think about. So what happens to your x and y coordinates? That's what we really want to know. So all of this goes, so we're all going our original, our xy's. So all of our xy's. And what is it turning into? What is it transforming into? And let's pick another fun color. Let's go with hot pink. So xy, this one becomes negative y, comma x. This one becomes negative x, negative y. So that's just kind of just changing the signs of your of your coordinates, and this becomes y, negative x. Now again, these are rules that, yeah, you might want to memorize. It's also important to understand how it's kind of also working. Let's get to some examples. So here are some examples. Let's just start off the first one, little example here. Let's say we had a point, and the point was at 1, 2. So let's just make a little 3x3 grid. And let's just say we had something at 1, 2. And we'll call it A. And so to say this is like 1, this is 1, comma 2. Remember, that's your x, and that's your y. And I want to rotate 90 degrees clockwise. So 90 degrees clockwise. And it's going to be about the origin. So you always kind of just need to remember that. So we're saying it's about this. This is the anchor. So if I was going to rotate this 90 degrees clockwise, so which way does clockwise goes? It goes to the, it's basically going to the right. And it's kind of going about here. So it's going to be going like, kind of like that, because this is the anchor. So this is the anchor point, the origin right there. So this is the anchor. And I need to be making 90 degrees. So 90 degrees. So it should be coming out something around here, right? That's kind of the idea. So where does it end up? Well, if we go back to our rules, so remember our rules, there they are. Whoa, crazy. It said if we go clockwise 90 degrees, it said that x, y, then becomes y, negative x. So remember our x, y's was 1, comma 2. So that basically means that goes over there, our x goes over there, but it changes the sign, so it becomes negative 1. And the y just flips over there and it becomes 2. So it goes there. So our new point should be 2, comma negative 1. So it should be, does that look about right? Okay, so obviously my lines are a little bit off, but it should basically kind of be about there. So that's how we kind of go and apply those rules that you had and visually. Now what if I went and said, though, not rotate 90 degrees clockwise, but what if I said rotate it, let's go 270 counterclockwise. So I did this. It would end up at the same place. So I could have said rotate 270 counter. and it would have ended up at the same place. And that's really important to kind of visually understand. Let's do another one, just for fun. I often wonder if all you math people out in the YouTube world, do you actually pause the video and see if you can actually go and solve things? I wonder if you guys do that. Let's go and make a 4x4 grid. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. Okay. And we're going to make a cool triangle because triangles are awesome. And we're going to make it at, say, 2, 2, 4, 2, and then 3, 4. Like that. Okay, so set 2, 2, 4, 2, and then 3, 4. We'll connect the dots. Jing, jing, jing. There we go. And we're going to go and do a rotation. And we'll rotate it 180 degrees about the origin. So here's the origin. This is the anchor point, and we're going 180 degrees. So if we're going through here, let's just call, maybe I'll just call these A, B, and C. So we're going 180 degrees. So if you actually took like some of your math tools and you went and drew this, you kind of see what I'm doing here. Like that, and you had to rotate it 180 degrees. It should all be landing somewhere around here. Okay, so imagine you kind of went and put your protractor on there and you went and measured stuff. We can go and do that if we wanted to, but again, most kids, most students do like the rule, and the rule is for x and y, it basically becomes negative x, negative y. So all you're doing is changing the signs. Negative x and negative y. So what does that a prime look like? So what is a prime going to look like? So if it was 2, 2, this is nice and easy. It would be negative 2, negative 2. And if you were 4, 2, that'd be negative 4, negative 2. And of course, if you were 3, 4, then you'd be just negative 3, negative 4, like that. Let's just go and plot those ones. So if I did negative 2, negative 2, it should be about there. If I did negative 4, negative 2, it should be about here. And if I did negative 3 and then negative 4, it should be down there. So I should get something that will end up looking something like this. I think my lines are a little bit off there, but it should be more like that. That's kind of the idea there, if you're going to go and rotate that around 180 degrees around the origin. So using the rules is really important. But I wonder, what if you had to rotate just around a random point? I'm glad you asked. Now, I hummed and hawed if I was going to go and actually film me doing this. I'm just going to try and talk you through it. So, is there a formula? Absolutely. Am I going to teach it to you? I'm not. Because this is mostly done kind of with kind of compasses and protractors. That's actually kind of what you want to be doing. So around a random point, and let's just say we had a square, and I wanted to go and kind of find the center point of rotation and the angle of how much did it rotate by. So let's say it was there. So I say A, B, C, and D, and then it went to here. And I have no idea how it did that. So A prime, B prime, C prime, and D prime. It looks more like actually a translation. But anyways, let's just say rotate it. I want to find the center of rotation. What you do is you connect two vertices. Okay, you connect two of them. So maybe A and then D and D. Okay, that's what you do. That's the first thing that you do. So the first thing, let's write this down. First thing is connect vertices. And the second thing that you do is you find the perpendicular bisector. Perp bisector. So there's lots of ways to do this with your compass to find your perpendicular bisector, but you need to find out where this would be. So the perpendicular bisector. So it's going to be basically, it's going to be kind of around there probably. And then you also find the perpendicular bisector of the other line, which would be kind of like around there. And then where those two perpendicular bisectors meet is the center of rotation. There you go, like that. And then all you do, so you do that, and then the final thing that you do is you go and you measure the angle. So you go and literally measure the angle between, say, the D and the D. So between here and here, what is that angle? So you have the center of rotation point by using the perpendicular bisectors, and then you go and you measure the angle, and then you say like, oh, okay, so it's going to rotate counterclockwise, probably about 80 degrees, something like that. That's how you go and do that. Boom. Try it. If you have some stuff at home, you can try that one by hand and see how that goes. Thanks for listening. Hopefully that wasn't too topsy-turvy and you learned a lot about how to rotate things. Until next time, have a great day.